Hello, everybody. My name is Garann. I'm joining from Glasgow. So I wanted to talk to you today about more robust servers with promises in Node.js. This is my contact info. Like Kimberly said, I'm a developer advocate at Vonage, which is a communications API. And I would be happy to talk to you more about that or about promises or anything else. So you can email me, garann.means@vonage.com, or hit me up on Twitter at GarenM. And I would be happy to have further conversations, or if something's happening while we're going through the presentation and you just want to drop a note to me about something related, feel free to. So what is a promise? Does anybody know? Does anybody want to talk about their experience of promises so far? Or shall we jump right into my explanation, which I promise you will be very cringy? Okay, no takers. So a promise is much like the song The Promise by the band When in Rome. It's an 80s song. If you haven't heard it, then this might not make as much sense. But the lyrics are, I'm sorry, but I'm just thinking of the right words to say. I know they don't sound the way I plan them to be, but if you wait around a while, I'll make you fall for me. I promise you I will, which actually aligns perfectly with how the promises API in JavaScript works. So we are doing something that is going to take an indeterminate amount of time, like just thinking of the right words to say. We don't know how long it's going to take to think of the right words to say. We have to handle a situation where they don't sound the way we planned them to be. Things are not as they expected. But we also want to make sure that we give thinking of the right words to say the opportunity to bear fruit. So we want to wait around a while. We want the listener to wait around a while. And then finally, at the end, we're still promising that certain actions are going to happen. There's something that we are guaranteeing is going to happen as the outcome of this, if the listener just gives us the opportunity to finish what we're doing. So that's a long and silly explanation for it. This is how you would often encounter it in your code. Basically, you have a promise, and you can resolve or reject it. And when you resolve or reject it, you can then attach .then with a handler, or you can attach .catch with a handler if you've rejected it. And you can basically say, I want this thing to happen. I want to confirm that this has happened, and only then do I want to do something else. And that's promises in essence. It's a way of handling your asynchronous code in JavaScript, of which there's plenty. And that is very, very true on the server. It's very true on the client as well, but on the client, at least we have a little bit of a static situation, whereas the server, of course, is just events flying around all the time. So then is kind of a funny word, because JavaScript is a very, very asynchronous language, and it's always been that way. And things don't always happen when you think. So when and then are kind of fuzzy concepts in the language. I think the most obvious example of this is hoisting. If you're new to JavaScript, you may be surprised to find out that things that you've written way down at the bottom of your code can be lifted way up to the top of your code and happen before you think that the code should have gotten to them. And that the code essentially doesn't run line by line in order. So when something is going to happen in JavaScript is not necessarily determined by where it is in your code. And that is something that can take a while to wrap your head around when you're new to JavaScript. And frankly, it can take a while to wrap your head around when you've been writing JavaScript for 20 years. It's a little bit of a confusing part of the language. There are all kinds of other examples, like modifications to shared elements or elements in the context that may happen within loops. And really anything that goes on in a callback is kind of all bets are off. There are so many different configurations of the context, the closure that you're in, when things run, how long they're going to take to run, error handling, all that stuff that can affect the order in which your code is executed. The promises basically allow you to specify what order that code should run in. So all of that fuzziness can go out the window if you want to, depending on how specific you want to be. Like you can specify basically when every single thing in your code should run if you want to get that detailed. If what you're doing is needing to be that specific, you have the option of doing that with promises. You can add that kind of guarantee to anything you want. So it's interesting to look back at how we ended up here. This is an example of something that we might have done in the past, where we have an asynchronous function that's going to get executed. And when that function actually does get executed and does its work, then we're going to set some kind of Boolean in the larger context outside the context that called that function, so that we know that it's completed its work, because we don't really have any visibility into that function. And maybe there are things that we don't want to do until that function is completed. Another example would be counters in for loops, and this happens a lot. Or this used to happen a lot. Hopefully, it doesn't happen as much anymore. This used to happen a lot just because if your for loop ended up being really long, sometimes JavaScript would skip ahead. Sometimes the items would overwrite each other. You could get into all kinds of funny situations. So having a kind of check within there to verify that you had completed the whole for loop, you were where you thought you were in the code, made a lot of sense for long running operations. And then finally, of course, we have set timeout and family, using timers to guarantee that things have time to complete, which I shouldn't say guarantee, because it's not a guarantee, it's a guess. You're hoping that within 1000 milliseconds, you're going to be able to complete whatever it is that you need to complete, and that work will be finished. This is weirdly one of the lightest weight solutions to this problem. And this is definitely something that we used to use a lot more on the front end, I think, than ever on in Node. But while it is lightweight, it's also, like, again, it's a gamble, because if something ended up taking a really long time, you wouldn't necessarily know whether you should be continuing to wait, or whether you should give up, or whether you needed to do something else or recover from a failure. That's one of the really beautiful parts of promises. Not only do they allow you to control how the code flows, but they allow you to identify whether something is taking a long time or whether something has actually failed, and like do different things specifically. So like you can say this is taking a long time, but I'm still waiting for a resolution. Or you can say, no, something's gone wrong within this other area of the code that I don't have visibility into. I want to reject that promise and message that up to whatever's waiting on this code. This is kind of the big tension in JavaScript. We have this event-driven front end that we've had for over 2 decades. Then we had this event-driven server platform show up that we've had now for over a decade. And then you come back to the people who are programming these things, who generally still think of programming as being procedural. We think of like instructions that we want the computer to execute, and we tend to think of them in order. Certainly some people have a different approach to it, but by and large, we still like take that kind of like programming basic mentality of like, do X, then do Y, then do Z. And that's an easy way to organize a set of instructions. And so trying to put that into the context of JavaScript, which is just like, if this happens, do this. Always, if this happens, do this. And when this happens and then that happens, like this and that don't necessarily have any relationship. So it can get really confusing. The original solution to this was the callback. And if you have a lot of experience with callbacks, which I assume you will, because there are still plenty of APIs that only use callbacks, you will know that they can get a little bit messy. Particularly if you're doing multiple things that are asynchronous and have callbacks, then you can easily end up in like way on the other side of your page, maybe even off the screen. Like your code gets indented and indented and indented every time you call back to something, and eventually like you're scrolling horizontally just to read it, which is not the problem in and of itself, but is definitely a symptom of a problem in terms of the readability of the code and the fragility of having things nested so deeply at that point, because it makes the context really hard to keep track of. What does the keyword this mean when you're seven callbacks deep? Like that's kind of an open question, because you're creating closures with each of those callbacks, and you're changing what objects you have access to. You're definitely changing what variables you have access to. And that's how JavaScript works. Like JavaScript relies on that sort of flexibility and those kinds of assumptions about the context you're in. So when you start nesting things really deeply, it can be really problematic. So we came along, or somebody came along, not me, I was not involved in it, but very clever people came along and created promises. And so let's look at how we can actually create promises within our own code. And at this point, if you want to follow along, you can. If you don't want to, that's fine too. But from now, we're going to start looking at code. So if you are interested in following along, I would suggest opening up a REPL. And if I'm just going to share my screen real quickly to show you that, just in case anybody is not familiar with it. So if I'm in my terminal and I just type node, then I will get a REPL, and I can say p equal new promise resolve reject. And that will let me execute JavaScript. So you can, if you want to, you can start trying some of this stuff out in your REPL, or if you have a scratch pad somewhere else that you use, something like a code pen or a glitch, anything like that, feel free to try this out. Okay, so going back to the slides. This is the basic, what I just did in the REPL is the same thing that is how you would basically go ahead and create a promise. So if I want to check if a file exists, I'm going to note that this function or this method is deprecated. Existing is not something you're actually supposed to use in Node anymore, because they don't like the way that the method signature is. But this is synchronously going to tell me whether a file exists. So I'm going to get a variable that tells me if a file exists, and then I'm going to create a promise using new promise. A new promise has it's these two arguments, resolve and reject, that are then going to be available to whatever are in the contents of this function here. And so if something exists, then I want to run resolve and pass it in the database file that I'm talking about. Otherwise, I want to reject the promise. And so all that's happening there is I've created this new object. This object by default has access to these two methods that do complicated stuff to maintain the infrastructure of promises as a larger concept within JavaScript. And I can access that just by creating a new promise object, which I think probably, like, to me, this always sounds very vague. It's like, how would I use this? So rather than looking at all the promise infrastructure here, look at the file exists. So I'm checking whether a file exists. I'm doing that synchronously. And then I want to take one action if it does. I want to take another action if it doesn't. And so I can now use this promise to check whether a file exists within the flow of doing other things. And let's look at, we're going to build up to examples that may make this a little bit more clear. So another way of doing this would be to just create the promise in line. So now you can see that I've eliminated a lot of that overhead. So I can also create a promise with just calling directly promise.resolve or promise.reject. That will create a promise as well. So now promise is a promise the same way it was in the previous slide. And then let's start doing things the way that we might actually benefit from them. So now I'm going to create a promise first. And within that promise, I'm going to call file system.exists, not exist sync like I was doing in the previous two examples, but exists plain vanilla, which makes it, because it's in Node, asynchronous. And so it's going to take a callback as an argument here. That callback still has access to resolve from the containing closure here. And so I can now resolve this asynchronous function when it comes back. So I can now let this function be asynchronous, which is what it wants to be. That's what that's how Node is designed. And I can let it run asynchronously, and then I can effectively use it synchronously by wrapping it in a promise and calling resolve when I get the result that I want. Or I could just use the file system promises built into Node and use access, which is not deprecated. So we're now at the point where these things are starting to be incorporated into the native APIs, the native front-end web APIs, and the native Node objects. And it's making it a lot easier for us to do these kinds of things with promises. It's looking like we'll get to a point eventually where we no longer have to think about this stuff. So it's useful now to think about, to learn about the flow of how promises work when you're using them in your code. Chaining them together is what we use them for. This is how we get the benefit. So let's say we have a database and we want to create it. Well, actually, so in the previous examples, we were creating this promise variable, right? Which is just in various ways checking whether the database file exists. So now we're going to use that. We have the same promise here, and we're going to say we're going to check whether the database file exists within promise, lowercase promise. In hindsight, I could have given this a better name so that it would be clear what I'm talking about. So then, with that promise that we are going to go and look to see whether the database file exists, we're going to do .then. And .then means not only that this is going to happen after we've run the whatever functionality is within promise and it's finished, but specifically that it's going to happen after it's resolved. There's a caveat to that, but we'll get to it in a later slide. So by saying .then, I am also saying, because I know the contents of this promise, that that DB file exists, because that's what promise is determining. So I'm going to say, essentially, if DB file exists, then take that DB file and create a new database. So I'll add here that there are other things that you can chain on to a promise. .catch and .finally are other things that you can chain onto a promise. And we will talk about those in detail in just a minute. But there's also a second argument you can pass to .then, which is a handler for the case where it's rejected. So .then can be both a resolve and reject handler. Normally, it's just the resolve handler because we keep things explicit that way. But I think that was the first syntax, if I'm remembering correctly. Was that you would have two functions here, the first one being resolve and the second one being reject. Okay, so now looking at a much more complex example. This is going to take a little while to unpick, but if you look, you may be able to see some things that are familiar from what we've covered already. Really all we're doing here is we're creating two promises, L and O. And then down toward the bottom, we're going to chain them together. So the promises are pretty simple. All that they're not even doing anything asynchronous. They're just promises for the sake of discussing promises. So we've wrapped a little bit of functionality in a new promise object, and we're going to append some content to a string, and then we're going to resolve them. And then down at the bottom on line 14, this is where things get interesting for us. So we will first run L, run that functionality, and then we're going to run O, passing nothing to it. And then finally, when both of those complete, then we're going to send a WhatsApp message containing the message that we've built up. So the work that we're doing here is not so much about it being asynchronous, it's about keeping this content in order. In the code that this is plucked from, obviously there are asynchronous things happening and there are loops going on within these two promises. And so we want to make sure that they happen in the correct order and that they both complete before we go ahead and send the message. And so that is how we would, that's how we could do that, just by chaining them together, saying that I want one to run and then I want the next one to run. So when a promise gets rejected, what happens? If we have, if we're checking that the file exists here, we also have the option to reject it. This is what we looked at in the first code example. So we can, like I mentioned, we can use then to cover both cases, both the case where it's resolved and where it's rejected, if we want to. And so we could, if the promise is resolved, meaning the file exists, then great, we can go on and do some file stuff with it on line 11. And if it's rejected, then we come down here to line 12 or to line 13, and we're going to create the file. We'll write an empty file that creates it. So now it exists. And this is exactly the same thing with different syntax. So here, instead of using two arguments to .then, we're going to use .then, and then we're going to use .catch to separate the resolve handler and the reject handler. They're both going to do the same thing, and it's a very straightforward way of doing things. You may have encountered this already, this pattern, and be familiar with it if you use .fetch on the front end a lot, or if you use fetch on the front end a lot. This is how fetch works, and you may have gotten to a point where you don't even think about it anymore. This is how you write fetch when you use fetch on the front end. Another way to do this would be to skip it entirely. So we're not obligated to do anything in particular with a promise once we have it. So we can say, if the file exists, great, the file exists. Like, I don't care. The only case I need to handle is the case where it doesn't exist. Then I need to create it. And then finally, I'm going to do stuff continuing on from there, because now I know one way or another that the file exists. Either it exists because it already existed when I called file system exists sync, or it exists because I just created it. So now I can do some stuff to it. And so that's how you use a rejection. A rejection is actually really valuable. It's not just informational. It doesn't mean like there was an error that you're just preventing from bubbling up and causing problems. Like it's a part of, it's a branch of your code. And you should think of it that way. Like it's a branch of your code. You don't have to put in a reject case within a promise if you don't need it. Like it's there to do something specific. A tricky thing with promises is loops, because loops are always tricky. Unfortunately, promises are really helpful, but they're not magic. They didn't come along and make it easier to deal with loops. And that's not a trait that's specific to loops. It's specific to the APIs for loops. We've gone through a lot of ways of dealing with iterables, and they've gotten better and better. But I think we only just recently got to the point where we had the ability to truly deal with them with callbacks. And so we're not yet at the point where we are able to deal with them directly using promises. Hopefully that day will come soon. In the meantime, we have to do something else. And if you're trying to think about like how you're going to use promises within a loop, obviously this isn't going to work. So like if you're in any kind of function that iterates through a loop or through an array or any kind of iterable, you can't resolve the promise within within an iteration of the loop, because that will resolve the whole thing. Like you don't want to resolve it on the first go round, nor do you want to resolve it on the last go round. Like you would have to do something other than this. So unfortunately, it's not this simple. It would be really nice if it was this simple, or if there was a second argument that we could provide to some of these handlers that would make it be possible to just resolve a promise. So what we can do is we can create an array, a second array that is just for the promises. So this is a little frustrating because first we're dealing with one array, which is going to be the one that we're getting back from whatever function, or the one that we're iterating over. And now we're going to have to create a second array that's just for each of those elements in the array, saying like, did this get resolved or not? Then once we have that array, we can use promise.all, and that's going to go through all the elements of the array and verify that they've all completed before continuing on to then, or catch, or finally, or what have you. Async await is some cool new stuff that does a lot of the same things that we've already discussed. It's not really changing any of what we've talked about so far, but it is changing the syntax of how we do it, is a good way to think of it. Async basically makes things promises. There's more to it than that, but at the most basic level, that's what it's doing. So if I take the async keyword and I put it in front of this function, then this function is going to return a promise. And so what I'm doing here is the equivalent of saying new promise, resolve reject, and then words, and then resolve write on line 2. And so it's the same thing, but you'll notice that the syntax is a little bit different in line 5 here, because now it's a function that's going to run instead of being a promise directly. So this is at its most basic level. Async is a different way of doing the same thing. It's an easy way to create promises, and certainly you'll notice that there's a lot less verbiage here than there would be in the expanded promises, new promise syntax. Await, on the other hand, makes promises synchronous, essentially. So within an async function, and it's important to note that you can only use await within a function that's been declared async, or within a module at the top level. So I can, within an async function, I can come down here and I can say, okay, it's going to take me a while to do this work on line 2 here, because I've got to go through and run this regular expression against something that I don't know how long it's going to be, or like how long it's going to take the regular expression to run. They can be a little bit slow sometimes. So I'm going to say await promise.resolve and then do this. And that's gonna allow me to treat that synchronously, so that I can say I don't want to do anything until this completes. And then I'll get the same kind of output from it. So if I send a string with a bunch of hashtags to this function, then I can execute it. I can wait for the code to complete, and then I will get my words back, and I can log those out. So now let's back up a little bit and talk theory again. Before we do that, does the syntax make sense? I feel like this can all be really abstract, and so I'm trying to go back and forth kind of between a little bit of theory, a little bit of syntax. But do you think that like the syntax is reasonable? Like it makes sense, like you can see how it would work?
Kind of. Yeah, it's like we put a wait. And so when that promise returns, and I guess, what's the word, not resolves, the result of that is saved into that hashtags, and it gets returned.
Yeah. So basically we're saying, yeah, don't look at this and say hashtags is equal to nothing because this hasn't completed yet. Wait for the result, and make it that promise. So it's a handy syntax. A lot of this stuff, I think actually all of this stuff is amply documented on Mozilla Developer Network, and that's a great resource for it. There's also this cool site. I'll make sure I get the URL correct. Unfortunately, I've lost the tab. Oh, it's just promisejs.org. So this is there's a site just dedicated to learning about promises. Has a lot of cool examples, but also MDN is always a good source of truth for what the individual methods do, and even several explainers. What does the W on line 5 mean? I have to go back and find my code. W is the argument that is coming in. So whatever's in the parentheses, when you resolve the promise, that's going to come in as this W argument in then. So in this case, we're going to run this regular expression against a string and expand it into an array. And that's going to come in as W in the then handler. Does that make sense?
Yeah, I think so. Thank you.
Okay, cool. Yeah, sorry. A lot of these variable names could be better. There's a reason that I am a coder and not a professional tiler of things, where there's a reason that the joke is that naming things is the hardest problem in computer science. Pick your cliche, I guess. Yeah, so if that makes sense, then let's go back and talk a little bit about how we would use asynchronous code, and how these little pieces of code actually get inserted into our larger projects. So very common scenarios that like I'm sure that you've run into these things in writing JavaScript would be fetch on the front end. Again, fetch does use promises, so you've had exposure to promises already if you use fetch. Data access is almost always asynchronous, and that has been the case for, I think, as long as I've been working with JavaScript. I can't think of anything where it really was synchronous. Loops, although not necessarily asynchronous, often tend to be that way because, loops can function as though they are synchronous, but end up being asynchronous fairly quickly, exposing their asynchronicity fairly quickly as soon as they contain multiple items. Node has always loved async. The Node project was started with the idea of creating an event-driven server framework, because previous server frameworks had obviously supported events because you get HTTP requests, which are a natural analogy for events, but had not necessarily taken an event-driven view of things. HTTP operations, like I said, those make perfect sense as events, like receiving a request, an HTTP request as a server, like that's an event. That's something that you don't know when it's going to happen. You just react to it when it happens. File system operations, you could make a lot of arguments about how to treat those, and certainly almost all of the arguments you would make would probably be represented in some version of Node, but they can take a while to complete at the end of the day. So treating them as asynchronous is certainly a reasonable thing to do. And it's interesting, I think, to note that the synchronous options in Node, a lot of those were added after, like in later versions of Node. So a lot of these things started out asynchronous, and then people were like, why do I need a callback to check whether a file exists? And so synchronous options were added later. The way that async works on the server is not a unique way of things functioning, but is a sort of unique set of functions. Requests, again, are event handlers. There's no way that these could be synchronous. There's no way you could say, I'm going to do whatever work is in app.get in my Express server just in a synchronous way. Like that code all has to be run within the handler, because otherwise it doesn't make sense. That's what a request handler is. The context of that only lasts within the handler. That's not completely true. Obviously, you have a session, but your session is something that is created by those events. Those events are what trigger the existence of that session, and to an extent, like you have to look up that session, and it's a piece of data that you pass around and access, rather than a context within which the handler functions. So the handler doesn't have access to like what happened the last time that request handler was hit. It only has access to data that it's given, and data that are constants within the server. And it's important, again, to note that all of these handlers have no relationship to one another, unless you're calling a chain of functions that somehow like branch into each other. The handler for one post request doesn't interact with the handler for the other post request. They're their own things, and they're not part of the same procedural piece of code. So once you get into server land, at least if you're like talking about like just the sort of front facing piece of the server that's going to take all your requests, you're talking about something that's completely asynchronous, just events flying around, and you're just catching them out of the air whenever they occur, and everything is asynchronous and very little is procedural. Data stores happen within the procedural code that you will redirect your requests to, but data stores, again, they can be very asynchronous, mostly because you just don't know how long they're going to take to complete, and you have to chain things together. You have to chain functionality together. You have to first create the database, and that is going to take an indeterminate amount of time, depending on how complex your database is. And then you may get access from multiple clients all at once. So you have to make sure that you have some system of not expecting things to be synchronous. Again, not expecting something to be the same when you start doing it up here as when you get done doing it down here, let's say. You need to offer control of the flow of the execution to something else, in this case, the data store. And in order to let the data store control access, you need to hand it off, and therefore you need to say, I'm going to join a queue, and I'm going to wait for you to do what you need to do to ensure that the integrity of the data, and then come back to me when you're done. And so this, what might seem like it could be synchronous becomes asynchronous that way. And then, of course, some queries just take a really long time to run. And there's a bunch of other stuff that takes a long time that you could do on a server, because you probably wouldn't want to do it on the client. Any kind of image manipulation takes a really long time, potentially sorting large data sets. So even once you have the data from the database, you may have to do some operations on it to filter it or put it in order. Building static sites, if you make some changes and you need to rebuild everything, that's going to take a while to run. So if your site's staying up and you're not building behind the scenes, but you need to generate a part of your site, regenerate it, that can take a while. And even parsing strings, like if you build up enough activity there, that can take longer than you might think, to the point where your string could change after you were intending to use it. So with all that in mind, I want to jump into some use cases. The first example is a pretty simple one. So I want to talk about just HTTP functions, not the HTTP handlers, but things that you might do as a programmer. And all of these are based on code that I'm taking from Glitch. Some of them are going to be before and afters, but you can have a little look at this one. At least is not going to particularly change. We're just going to discuss the code here. So if you want to look this up on Glitch, you can. I hope that you would be able to copy this if you're looking at it. This URL here. So let me come back here. Sorry, I'm trying to find my, here it is. Okay, so if we're looking at this code, this is some code to just write a simple little messaging bot. And it is all fairly normal stuff that we don't need to look too deeply into until we come down here to line 22. And this is where it gets interesting from a promises perspective, because much like fetch on the front end, the Axios library on the back end is using promises automatically. It basically works exactly the same way as fetch, but it's on the back end here. So you can see here an example of using promises to do HTTP operations. So this is going to send a post request, and it's going to put it all together and generate it, et cetera, but it's going to get a response, because for every HTTP request sent out, there's some kind of response, and that response should be handled. In this scenario, I'm not really doing anything with it, but if I wanted to see what's in it, it's already being logged to the console. So you can get back the response for this, which is basically just going to tell you whether the message succeeded. But there is some information here if you were in a real world scenario that might be useful to you in terms of keeping an eye on the messages that you've sent out. So you get a message ID, for instance, to let you know what message was sent by this API endpoint. And so this is I would say this was certainly the first example of promises that I had ever worked with, was fetch and Axios and things like that, creating HTTP requests, because it's a very natural fit, something that obviously needs to be asynchronous. So so this is what they look like in action, and this is code that you can take and play with. If you want to create a WhatsApp bot or a messenger bot, or any kind of bot with Vonage's APIs, you're certainly welcome to. I have a coupon code for you. I'll just grab that really quickly, and I'm going to paste it in so that you can access it. Sorry, I've ended up in iMovie somehow. So here is a coupon code if you want to try and make any of this code work that's on Glitch. You will need sorry, I can't seem to find Zoom. Okay, I'm going to stop sharing my code. So here is a coupon code. If you need credit to use Vonage's APIs to make any of these examples work, feel free to grab that, and then you'll get some credit so that you can try these things out. So that's just a straightforward like use of promises within an API that already supports them. And that's obviously the ideal way to go, is like that all the APIs and all the tools that we would want to use already have promises built in. Unfortunately, that is not always the case. So The next example is going to be a before and after. How we can do this traditionally with nesting and whatnot, and then how we can use promises to improve it. So this is the original code for this, and what this code is doing is it's taking an uploaded image, and then it's sending it to someone via WhatsApp. And because of pretty much the limitations that that promises exists to resolve, there are some compromises within this code. In the first instance on line 53 here, we're just grabbing the first element of a potentially limitless array rather than loop through it. Then down on line 55 here, we're using rename sync instead of renaming things asynchronously as Node would prefer. And then we're within this dot send here. That's when we're actually using this user variable. So we're getting that well before we need to use it, just in case it takes a while to access this file. So there's a bunch of little things that you might not notice, and indeed they might be things that you do in your code just to keep things where you expect them to be, that we can rethink with promises. So if we come in here and we write the same thing now using promises, here's the same function, and it has all the same, it's doing all the same things, but it's gonna work a little bit differently. So now we're gonna make rename photo a promise, and within rename photo, we're going to do that rename operation asynchronously. So now it has the same two arguments, the from path, the to path, but then it also has this callback here. And within the callback, if there's no error, we're gonna go ahead and resolve the promise. Then we're going to create an empty array. And so if you remember back to a few slides ago, we're creating the empty array so that we can fill it up with brand new promises. And so now we're going to say users.forEach. Oops, you can tell that this is not live code because, oh, here we go. So yeah, users is up here. So here's the JSON array of contacts. Now we're just going to take it and directly loop through it. And then for each element of that array, we're going to push a new promise onto this array of promises. And that's going to do all the same stuff, but after sending the message, it's going to come down here and either reject or resolve it. And so then finally down here at the bottom, we're going to use promise.all to run these operations. So first we're going to rename the photo, push that onto our array, our new array of things that we're going to run as the first element. And then we're going to spread whatever's in messages.sent as the subsequent elements of that array. And so we will basically just say, first rename the photo, then send a message to the first user, send a message to the second user, etc. And then when all that's done, when we've done all that, then we're going to send a response back to the client that initiated this, the web client that initiated this. You can see this as a post from the web, just saying that the data was sent. So that is a way that we could go and rewrite a piece of code with promises. And let me know if you would like to actually walk through any of these rewrites in more detail or anything like that. And so the final example is I think the most complicated one. And so this is updating a data store when you're completing a purchase. Coming over here to the code, this is what that looked like to begin with. So this function here, complete by, is the function that I think could be rewritten. And my hint that it could be rewritten is that it goes indent, 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 and I can see that every time it's indenting, there's another db.run or db.get, which is a good clue that this is something that I could put in a promise. But just the level of indentation here and how much the bulk of the code is all the way indented is always a sign that there might be a less fragile way of handling your code, and it could be rewritten to use promises, I think. So you can see that what this code is doing is it's going to get a state variable, or it's going to get the state of an interaction from a database. Once it has that state, it's going to insert a new row into an orders table, and it's going to use that. A piece of information stored in the state to create that order. Once it's created the order, then it's going to update the things that are for sale and say that the thing that is being purchased is no longer available for purchase by setting it to be inactive. And then it's going to send a notification saying that that the item has been purchased. Is also, if there's no error with setting the item to be unavailable, going to notify the person who sold it. And then finally, it's going to update the state to say that it's going back into a waiting state, which is something specific to this application. I won't go too much into it unless you have questions about it. But basically, there's just a bunch of stuff that this function needs to do, and this is only like 1/3 of the work of purchasing an item within this application. So we have to first initiate the purchase with this buy function up here, and then we have to notify the seller, which is a bunch of other work down here. So this is the bulk of work of purchasing something, but it's only a piece of it, and this is what this piece looks like. So it's possible that it could be streamlined a bit. I see that there's something in the chat. Okay, thanks, Jay. Bye. So if we were to rewrite this, we can go ahead and use promises to pull this stuff apart. So like, at least in the first thing that we can do to improve this is we just won't nest it so deeply, because there's just all kinds of silly problems that you can encounter, like missing parentheses and things like that, that we can easily alleviate by just using promises and just not nesting things. So what we're going to do here is we're going to first of all, this ID here is coming from state.memo right here. So this is the piece of information that whole thing was wrapped in its containing function just to obtain. So rather than wrap this all within the handler for this database query, just so we have access to state.memo, we're going to make state.memo a variable that's available to everything within this function. And the really cool thing about promises is that because of the way that we're guaranteeing the order of execution, we can now do that safely. And so now, even though I won't know at the point that I'm using ID right here in this database query whether ID has been set, I will know that I'm going to guarantee that this gets run, that order gets run after get ID. And in doing so, I can guarantee that ID is available. So this is where it becomes really handy, is when you want to control the state of your context. So yeah, this is basically all we're doing here. Like this is very much the same code, just rather than embedding these things within each other, we're saying resolve, and then we exit back out. So we run the database query, we get the result, we set the value, and then we resolve. We exit back out onto the next thing. We insert into the database. As long as there's no problems, we resolve. We exit back out. And finally, we make it inactive. We notify the seller. We resolve. Exit back out. And so then we can say we want to first get the ID. Then we want to get the order, and you see that we're not passing any values to these because the important value again is the ID here, which we've made available in the context that these are all running in. So we're going to get the ID, then we're going to make the order, then we're going to make it inactive, and then finally we're going to do the last operations that were embedded way down at the bottom here. We're going to send a message, which is not super critical to the flow of operations, just it needs to happen at the end. And similarly, we're going to update the state to say that we've completed the purchase, and that's not critical to anything else, so that can happen at the end. And so that's how this all gets reorganized using promises. And that is essentially that's promises. That's how you use them, and that's what they can do for you. I was going to try to think of something clever to sum it up, and I couldn't. So my summation was just, does anyone have any questions about any of that? And is there anything that you would like to talk about in more detail? Because like the promises is one of those tip of the iceberg topics. Like it's good to have like the introduction, but then like I feel like once you start using them, like you end up having a lot more questions. And once you start using them for something serious, you start having more questions. So I think that we probably don't have a use case that we could all walk through and all participate in this setting that would demonstrate the complexity of the questions that you might run into. So all of the do you mean, Erica, do you mean the after versions, the edited versions?
The code that you just walked through on VS Code with the before and after version.
Yeah, the after versions I don't have on Glitch. Let's see, how can I share these? Well, I can paste them into the relevant Glitch projects just as a comment, so that they don't mess with anything, and then they will be then they'll be in the same places as the URLs that I already put there. Will that be helpful?
Yeah, that would be great. Thank you.
Great, I'll do that.
If nobody else does, sorry, I've got a couple of questions. They relate to kind of mostly your earlier slides. I was wondering if you could go back on those. The first one was related to the set timeout.
Sure.
It would be like number 9 or 8, possibly.
Let's see. No, not quite. Here we go. Okay.
Okay, cool. Yeah, I mean, it's always been a question in my mind when using set timeouts, is the 1,000 the time it will wait and then give up, or is that the minimum time until the code is resolved?
So this is specifically it's supposed to wait 1,000 milliseconds and then execute what's in this callback here. So all this function here within that's the first argument of set timeout should be executed after 1,000 milliseconds. In practice, you can't really guarantee that, but yeah, it will be at least 1,000 milliseconds, depending on what else is going on.
Okay, so what's in the function that would be synchronous and expect it to resolve quite quickly.
After 1000 milliseconds, yeah.
Okay, so it's just a pause. Don't execute this code until at least 1000, well, until a minimum of 1000 milliseconds has passed.
Exactly.
Cool. Yeah, the other one was, I think, slightly further on. It was to do with one of the short-form versions of creating a promise. If you could scroll forward, I'll try and stop you at the right one.
So now we're getting.
Yeah, that one there. Yeah. When you say let promise equals promise.resolve, does that return a promise or does that do the resolution?
Yeah. So it does both. This is going to promise, lowercase promise in this slide is going to contain a resolved promise.
Okay. Cool. That was it. No, thank you. Yeah, those were the main questions. Yeah.
Great. Anything else anybody wants to talk about?
I mean, more generally, yeah, as you were saying about how do you conceptualize promises in your head? I've always struggled, especially as you're just saying about a resolved promise or a rejected promise, or what is it you get back from these things, and how do you imagine them in your mind?
I think that the best way I have of picturing them has to do with function delegation. A pattern that the pattern that you use to create a callback is the way that I imagine them, which I don't think is a particularly user-friendly analogy, unfortunately. But that's basically how I imagine them. Like usually when you talk about a function, like you're either declaring it or you're calling it, right?
Mhm.
But we don't do a lot of passing functions around as functions. We do that in callbacks, but we always do it via a mechanism that's been created for us. And so when you're writing an API, you have to take the callback that's given to you, wrap it up, make sure that the context is correct, and then say how to execute it and when to execute it. So you can't just like call it the way you would normally call a function. You have to delegate control to it. And so that's how I think of promises, is like giving us the ability to take code that essentially we could only previously either declare or we could execute, and being able to move it around as an object. So it's like a meta, I guess, like a meta control for your code, where you just like kind of swoop in with the carnival claw and like pick up pieces and move them around, keeping them intact and reposition them. I don't know. That's probably not making anything any clearer.
No, it's good to get an idea of how people think about these things, and yeah, they're not easy concepts for the human brains. I've always struggled with them myself, so it's good to know sometimes that there isn't a simple way that I've been missing to think about these things.
Yeah, it's a difficult, like I think it's a difficult thing to conceptualize, because it is such, like, it's an abstraction that is only an abstraction. Like so many things in JavaScript, like they connect to something like very tangible, like even set timeout, which is just like you said, it's a pause. So it's very abstract. Like it connects to something like sort of very concrete, like in that there's a number of milliseconds. You're like, okay, well, if nothing else, I know that the code execution will wait this number of milliseconds. Like, and then all the abstraction stuff that happens around that, like you can discuss that like with the number of milliseconds as sort of an anchor, whereas promises, there's no anchor. It's just abstractions. And yeah, you just kind of, it's kind of one of those, you really have to start playing with it to be able to appreciate it, I think. I think the ability to understand it definitely comes through trying out examples. But luckily there's like a lot of really good documentation. There's the site that I pasted is very interesting, like very focused approach to promises. Again, MDN has just tons of articles on promises, and you can check those out. I think that CodePen and Glitch may be even more valuable places because you can just jump right in and play with the code and see what's going to happen when you tweak things around. Okay, thank you, Carrie. Anybody else have any questions?
I'm still kind of learning about this stuff. That's why I'm here, I guess, attending this. So thank you. And in my mind, and as I said, I'm still kind of in the learning process, but it seems that it kind of seems like a way to deal with this asynchronous code, making it look almost synchronous, so that you're saying this and then that, and then perhaps the fact that you use the then as well.
Mm-hmm.
And yeah, and so that's, do I have a good feel in this respect, do you think? I mean, is it okay to?
Yeah, you're basically forcing it to be synchronous. You're saying like, go and do your asynchronous thing, that's fine, but everyone else is gonna wait for you. It's like when your toddler won't finish lunch so she can go to the park. You're like, we're all just gonna sit here and wait for you while you do your asynchronous thing. Like, you can be asynchronous, go ahead and complete your asynchronous execution. But we're not going to move forward with this other stuff until that's happened. So yeah, you're essentially like taking the asynchronous code and making it behave in a synchronous way, but only to the extent that you specify it needs to, which is kind of a beautiful thing, because like you can still let it be asynchronous for the parts where they're either contained within a promise already, or they just don't matter to the what all the rest of the code is doing.
Yeah, and it's more like it's not your concern.
Mm-hmm.
So in a way, it's not synchronous, but you're kind of setting it up that way, in a way that allows you not to worry about, you don't have to worry about assignments not being fulfilled or anything. They will be when, so you can free your mind of that and think about other things.
Yeah, exactly. I think that's a really good way to look at it.
Thanks.
Struggling to know if this is how I've always, well, one of the ways I've learned about, how JavaScript handles execution context and the stack and everything. That there's the kind of the main stack, the main execution order. I don't know the correct terms that are used for that. And then there's a secondary kind of afterwards stack. So JavaScript isn't particularly asynchronous, it's synchronous, but just handles things in a what looks to be a synchronous way. So everything that's not a promise is kind of handled in the main flow of execution. And then anything that it finds in that, when it's building up this kind of these runs, is if it's a promise or asynchronous, it's going to move to one side and put in a separate queue. And so once the first execution run completes, then it will start to look at these other things.
Kind of, yeah. So JavaScript is normally single threaded. So like there's only one thread of execution, and so if something is happening, then something else will pause, and like only one thing will be happening at once, basically. So if we've said that that we're going to wait for we're going to await some resolution, then if there is something else that that can happen while we're waiting for that further down in the code, so probably after promise.then or anything like that, then it may continue. It may. That's something that I think a lot of people have struggled with for years, is that there really are no guarantees when things are going to run. Like they will all eventually complete, assuming that all the code is reachable, but there you don't really have a lot of control, and so that's why we have promises and callbacks and all these ways of trying to address the order in which things happen, because yeah, it is single threaded, and every once in a while you can get into a situation where you're doing something that takes a long time to return a response, and JavaScript will continue on and do something else because it thinks it should keep itself busy, and you can get into a weird situation with that, with shared variables and things that are above it in the context and whatever. So yeah, promises are a way of definitely controlling the fact that it's single threaded, and it may move on to other tasks if it's not told what to wait for.
And does Node on the server kind of run in the same style as browser JavaScript in that sense?
Yeah, actually, Node is more like that than browser JavaScript at this point, because I can't remember how many. You can do a lot more stuff simultaneously in the browser than in just JavaScript, which is what Node is basically. And there is now threading in JavaScript, and that's not a discussion I've kept up with, because if anybody has experienced trying to control threading in older school languages, at least for me, that's one of the reasons I'm a JavaScript developer, because I didn't want to do that. Yeah, there's been talk of introducing control for threading in JavaScript for years, and as far as I know, it's still not a part of the default in either Node or the browser. But the browser obviously does a lot more stuff. Like the browser will devote several different threads to like going and prefetching resources and things like that. So there's a lot more happening in the browser.
Okay, cool. No, that's fine. I was just wondering if there's any key differences, but yeah, that makes sense. Thank you.
Thank you so much, Garann, for coming along today, giving up a bit of your Saturday morning to do this workshop. I hope everyone found this useful. As I also said before, I'm intrigued to know what people think about these weekend workshops. And so, yeah, huge thank you, everyone. Enjoy the rest of your Saturday and weekend. And yeah, see you all soon.